All right, so one thing I like to do, I like to record my class and then I give you guys the link so that you guys can review, rewind, pause, like in case you missed something in class. So that's one of the features of my class. Um but yeah, let's jump into it. So as I said, I'm Professor Chris Lee. I'll be a professor for this semester. Um did everybody have a chance to look at Brightspace?
Yeah, I did, but I didn't see any um content. I don't believe from your
Nah,
side.
no content is there. No content. Just announcements. Just announcements. All right. So for those of you that didn't have a chance to look at it, let's take a look together. All right. I'm just gonna All right, let's take a look at this together, shall we? All right. Give it 1 second to load. All right. I think we're good. All right. So this is my Brightspace. You all have your own, right? You see, I posted a couple of announcements here, right? So let's talk about the first one, right? So as I said, I'm Professor Chris Lee. You guys can see my email when you go to the main page for the class right here. But I'll also write it for you guys later if you guys need to see it again. Just give it 1 second. So right here, there's a little profile widget here. I don't know how to upload a picture, so it is what it is. But this is my email. You can also get it by clicking this little button right here. All right. In case you guys have any questions or you guys need any clarification on anything, you guys can always email me. All right. No problem with that. All right. Sometimes I will admit I'm a little slow to reply. Like just allow me like a day or so if you see it if you see that I'm a little slow. Usually I'm pretty fast, but sometimes I need a day or so just to catch up. All right. Um Next thing I want to talk about, let's talk about like my post right here, right? So I posted some formula sheet packets here and a little cheat sheet for web work, right? So in Math 23, you're going to be given a formula sheet, right? I personally give you guys two formula sheets. I give you an algebra formula sheet and I give you a statistics formula sheet, right? You guys can use both of them on your exam, right? If you guys would like to look at it, these are the links for them, right? Just click it and open it up. You guys can download them, print them, right? On test day, you could bring them with you and use them on your test as well. All right. Um, Next thing I want to talk about is calculators. I do allow calculators in the class. I don't really have a preference on a calculator, but I do have a recommendation on a calculator. So I like the TI 36X Pro. That's like my favorite calculator of all. Um, Also the graphing calculators are really good. The what's this thing called now? I'm about to say Nspire, but I don't mean it. That's a good calculator too. You guys can use that as well. Um, the 84, TI 84, right? That's a really good graphing calculator as well. So again, I'm open to whatever you guys would like to use. The 36X Pro, I believe, is like 20 bucks at Staples if you guys want to buy one. If you go to the library, right? Particularly the media section. So to get to the media section, you walk up the stairs and then you just make a left, right? It's on the left-hand side, right? That little space where there's someone that you can ask questions to. They actually have calculators there that you guys can borrow for free, right? Now, I can't remember their lending policy. I know that they have a 3 hour policy. I know that they have a 3 day policy. I want to say that there's a 3 month policy too. I could be wrong about that. So y'all might need to just go there and check it out if you guys want to borrow one of their calculators. Their calculator is a graphing calculator. Again, I'm not picky about which one you guys want to use. Whichever one is easiest for you, like go ahead. All right. And then what else I want to talk about? I want to talk about this last one right here. This is a web word cheat sheet, right? So this is basically a sheet that you can use that's going to help you with your homework, right? It's going to help you with entering answers in for your homework. Some of the answers that some of the questions and the answers that you might plug in, there might be a little ambiguity, so to speak, with entering the answers. Like I'll give you an example. Let's say I asked you what is the absolute value of -2, right? Actually, wait, no, that's a bad example. Let's say I gave you an equation, x squared is equal to 4, right? And when you solve that equation, you actually come out with two answers, +2 and -2. So to enter in that answer, you'd have to actually write -2, comma 2. You could also swap it. You could say 2, comma -2, right? But just to know that's how you would enter the answers. So like little hints and tips and tricks like that is in this last PDF right here, right? I try my best to remember to attach these PDFs to all my updates. um, if I don't, just go on Brightspace and scroll down to an old update and it'll be right there. All right. Any questions so far? I know I might be talking a little fast. Everybody good?
Yeah.
Yeah, I'm good.
Yes.
All right, cool, 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 cool. All right, so let's move on real quick. I want to talk about the course content right here. So over here, this is your syllabus. All right, you guys can just click on that link and then click on the little PDF right here, and you'll see the syllabus of what we're gonna do for the semester. All right. Whoops. Hold. Wait to the bottom. Excuse me about that. All right. So here we go. So again, this is 23.5. So we're gonna be doing probability and statistics with algebra. All right. So again, this is the calculator that I recommended, the 36X Pro, right? No pressure to get it. If you don't want to buy it, you can borrow it from the library. All right. These are our textbooks right here, right? I'm not really focused on the last one. It's just really these two. But the first textbook, that's our main statistics book right there. Get it if you want to. I don't really think you'll need it, but if you want it, no problem. All right. So
That last part again? You said
you could get it if you want to. Yeah. So some options you have for getting the textbook besides just buying it, right? The library has it on reserve. You guys can always go to the library and borrow it if you just wanted to do some reading, no problem. The math tutorial lab, which we'll get into a little bit later, they actually have copies of the book there as well. So you can actually go there and do your homework if you want. I suggest that, but optional if you guys want to or not. All right. Um, so let's look at the course description. So this is probably in statistics, a course with elementary algebra, topics integrated to support the statistics. So probably in statistics, topics include organization and presentation of data, right? Measures of central tendency and variation, correlation, linear regression, elementary probability, the binomial and normal distributions, right? Sampling distribution, central limit theorem, confidence intervals, student T distribution, hypothesis test. Elementary algebra topics include fractions, percentage, adding and subtracting polynomials, linear and quadratic equations, literal equations, solving word problems, inequalities and functions. All right. And then it says that this course is equivalent to Math 23. It sounds like a lot, but I promise you I'm gonna make this as easy as possible. Promise you that. All right. This is not an extremely hard course. The hardest topic that we're gonna go over is the one that we do today and tomorrow. which is adding, subtracting, multiplying, dividing. The rest of the course is easy. Statistics itself is easy. I promise you. You guys will get through no problem. All right. So, this is just talking about pathways, blah, blah, blah. All right. Please do your own work, be academic integrity, all that good stuff. I want to talk about this accommodations, right? If anybody is allowed accommodations or you were allowed accommodations in the past and you'd like to get them back, etc., right? This is the information for the Disability Service Office at campus, right? That's their email, disability.service@bcc.q.edu. They're located in Low Hall, room 211, and that's their phone number, 718-289-5874, in case anybody wants to call. Um, some things that you can do with the disability service if you want to take your test in, like, let's say like a really quiet area. You don't want to take it in the class. You don't want to be surrounded by the people. You just want to be like by yourself, so you could just like zen out and get the best grade you can. You can do that there. There's a lot of other accommodations that I don't have time to go get into, but if you're interested, please, reach out to them and they'll set you up, you know. So it's a really good thing. I used to actually work with them. I was a tutor for a disability office for a little while. They're really good. I really recommend them. All right. So last but not least, these are the topics that we're going to be going over, right? For the whole semester, actually, right? On the left hand side, these are statistics topics. Right hand side is our algebra topics. So each week we're gonna like have both, a little bit of both, a little bit algebra, a little bit of statistics each week. Boom, 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 like back and forth. All right. But everything that we do in algebra is directly correlated with making like life better or more understandable for statistics. Okay. So any questions so far?
Um,
Good.
all good.
All right. Let me come over here. Excel is like my favorite thing to teach out of. All right. Y'all not required to do any in Excel work here, but this is like my favorite platform right here. All right. Give me one sec. A little bit more about me. I'm actually an alumni to BCC as well. So a couple years ago, I was sitting in those same seats that you guys are right now. So I understand the struggle. I know what it's like to be a student. I don't know what it's like to get a snow day. Right? Back in my day, like when it snowed as hard as it did yesterday, we had to still go to school before they decided, you know what, let me give y'all a half day so y'all could get home. You know? Terrible. But I'm personally happy about our snow day for today. All right. So what else I want to talk about, right? Some things that we're going to do in statistics, right? We're going to sort some data, analyze it, present numerical data using sample spaces, right? Measure central tendency, all that good stuff, right? We're going to recognize correlations between data sets, right? That's really important. Express linear correlations using the least square regression, right? Determine the strength of a correlation. We're going to predict outcomes using basic techniques of probability, permutation, combination, counting techniques, tree diagrams. All this is going to be really fun, right? We're going to recognize the features of a binomial experiment and apply the binomial probability distribution to it. All right. We're going to do normal distributions, right? Well, probably one of the most dopest things we're going to do is something called inferential statistics. We're going to take samples and we're going to make educated guesses as to what their population parameters could be. More on that to come, right? This is all good stuff, good stuff, good stuff. A little bit of a breakdown with the class, right? So, for your exams, right, we're going to have three in class test, right? I'm gonna take the best 2 out of 3 test, right? So we'll have 3 tests, right? Best 2 out of 3. And this is gonna be worth 30% of your overall grade. All right. Next, your homework. All right. So I'm gonna be giving you guys homework on web work. Right? I made an announcement about how to log into web work, but your homework, right? This is going to be 37% of your grade, right? So do your best to do your homework, all right? Give me 100 on the homework. I don't care how you guys do it. If you guys want to use the calculator, if you guys want to pair up in a group and work together, if you guys want to go to tutoring and get help on the homework, just get the homework done, right? The homework is what I use to make your test, right? I'm talking about straight up copy and paste, right? If you do your homework, you have all the answers for your test. You can't go wrong. Can't go wrong, right? And last but not least, we're going to talk about our final, right? So the final will be 33% of your grade. Now, I don't have the date to give you guys for the final exam. All I could tell you is that it's going to be in May. It's going to be during finals week. If I had to assume, I would assume it's on the Thursday of finals week, right? I could be wrong though. I could be wrong, but I would assume it's going to be on that Thursday. So I'm talking about like May. Bear with me 1 second. I'm just trying to grab excuse me, a calendar real quick. Talking about like May 21st. Again, I'm guessing, right? It could very well be May 26th. Or no, not 26th. I can't say May 25th because May 25th is actually a holiday. So yeah, I think it's gonna be the 21st. I could be wrong though. All right, so just keep your finals week open. Whatever day it lands on is whatever day it lands on. I'll let you guys know when I have more information about it. All right. Yeah. All right. Let me also 1 sec. I want to introduce you guys to the tutoring link. 1 sec. Let me go back here. So I'll get another tab open over here. So this is how you get to tutoring, right? I just want you to Google BCC and WC online. All right. Just click the first link. Okay. So this is your portal for tutoring, right? So you guys can just click here. And then if this is your first time, you're going to need to click right here where it says register for an account. Now, some of you might have gone to tutoring for writing, for example, in the writing center. This is the same portal. You don't need to create a new account then, right? You have an existing account in that case, right? But if it's your first time, click register for an account, fill it out, boom, 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 and then you should be good to go. Now, let me go back to the home real quick. Okay. So unfortunately, the website is down for math at the moment, but there would be a link here that would say like math in-person tutoring or math online tutoring, and all you would have to do is click there, and then you'd be able to make an appointment, but it's not up as yet. It should be up, I'm thinking February 2nd, right? So I'm gonna probably revisit this conversation again at that time. But for now, for this week, just know that like it's not open, the tutoring. But just to tell you a little bit about tutoring, tutoring exists in two modalities. We have both in-person and online tutoring. In-person tutoring takes place in CPH room 303. Once again, that's CPH room 303. Let me write that down so you guys can see. That's the Carl Panach building. You know that building that has like the arch in front of it? It looks like a Lay's potato chip. Like it has like a arch thingy in front, right? And people just walk right underneath it, right? So that's the building, right? CPH 303 on the third floor, right? So you can go there for tutoring, do your homework, ask questions, hang out, whatever, right? They have computers there, they have calculators there. So you can actually go there and borrow a calculator in case you forgot yours at home or something like that and you want to do your work. Um, in addition to tutoring in person, right? In person, there is online tutoring on Zoom as well, right? So very similar to how we are doing class today. Same game. Like there's a link for the Zoom tutoring. You click it, you go in. There's gonna be a secretary there. They'll ask you for your name and your information. Then they'll set you up with a tutor. All right. The online tutoring. I'm not gonna say that there isn't a group aspect to it. There could be, like, let's say that everybody in, well, not everybody, but let's say that three people in this class got together and said, all right, we want to go to tutoring at the same time. They might group you guys together in one room with one tutor. But for the most part, it's online tutoring is kind of one-on-one, right? It's one of those situations where, one person's talking and you can't have like three or four people talking at the same time. In-person tutoring is like a group tutor, like a group tutoring. So I'm not saying that you won't get one-on-one in person, but don't expect it every single time. Especially when we come down to finals time, right? Finals time is busy, right? But if you went right now, you're probably gonna get one-on-one support right now, you know? Um, Something else I want to mention about our class that's really, really special. Other classes don't have this benefit, right? So we are actually part of a sort of math block that they have at the school, right? So what that means is that you guys are actually going to have your own personal tutor in the class. Right now, the tutor is will only be here one day a week, which will be on Thursdays, right? And on your Thursday class, you'll go to class, and then right after, you're gonna stay after class for about like an hour or so, right? And in that hour, you're gonna get to ask questions if you want any clarification with the material. If you guys want to start your homework, you guys can do that. you know um haven't really like figured out what will be best as yet, but like I'm gonna kind of read the room. Like if I see that there's a topic that most people are struggling with, I might say, all right, let's for that session you guys focus on that. If everybody is good, I might say, you know what, just do y'all homework. When y'all done, then y'all could dip. All right, so that's gonna be another benefit. You guys will meet your tutor on Thursdays, on Thursday, this week Thursday. Jovine is her name, lovely lady. All right, and we'll elaborate more on Thursday about that. All right. Any questions so far?
Oh God.
Anybody? Good. All right. Um, please try and get into web work. All right. When you guys get a chance, your username and password for web work. This for everybody. Your username and password for web work is your first name followed by your last name in all in lowercase letters, right? So for example, right? Let's say that my name was John, I don't know, yeah, I don't even know. I'm trying to think of a short last name. I'm gonna say John Lee. My last name is short, right? So the username and password, right? Username and password would be John, no space, one word, Lee, just like that. Right? All lowercase, no space, no dot, nothing. Just John Lee. That's your username and password. That's for everybody in the class. So you guys try log in. I did post some homework for today. The homework is very, very simple. As I said, today is going to be a review. So you could probably blast through it. It looks like when you go in, is it looks like I'm giving you guys four homeworks, but I promise you each question is like 2 minutes time, right? It's also a good way for you to get used to your calculator, right? Like figuring out where every button is, that because you don't want to be learning the calculator on test day, you know? So this is a good way to like get that out of the way. All right. So let's jump into what we're going to be talking about today. We're going to start off a little slow, right? But we're going to pick it up as time goes on. All right. Hold on one second. All right. So the first thing we want to do is called Introduction to Fractions. All right. Bear with me. We got to go through it. I know y'all all probably know what this is. All right. Just take it as a win. If you guys are bored, y'all could log into web work and just do your homework while I'm going through the lesson. That's fine as well. All right. So introduction to fractions, right? Growing up, the first I'm sorry, say again. My fault. Can you repeat the question? I'm sorry. All right, we good then. All right, so growing up, the first numbers we encountered are whole numbers. So that's like 0, 1, 2, etc., right? 3, 4, 5, 6. These numbers, with the possible exception of 0, are as concrete as numbers can be. While I may not be able to picture a 3, I have a clear idea of what 3 books mean, $3 are, 3 fingers, etc., right? So the whole numbers together with their opposites, negative whole numbers, are called integers, right? As soon as we start dividing whole numbers, though, we encounter the problem that the quotient of two whole numbers may be a whole number. A fraction is a symbolic way of writing a quotient, which is the result of dividing two numbers. In this way, the operation of division is built into the notation of a fraction. All right. So anytime you see a fraction, right, that implies division. That's what that means. All right. All right. So for example, right, 1 over 2 is a symbol representing the number that results by performing the operation 1 divided by 2. Some things to notice right away. A fraction is one symbol consisting of two numbers separated by a bar. The bar represents the operation of division. So one number is written above the bar, it is called the numerator. The other number is written below the bar, that's called the denominator. The two numbers play different roles. After all, division is not commutative, right? Commutative means that if I was to say 1 over 2, excuse me, 1 divided by 2 is equal to like 2 divided by 1. That's commutative. That's not true, right? For division. So 1 divided by 2 does not give the same result as 2 divided by 1. So 1 over 2 is not the same as 2 over 1. For the first few chapters of this book, most of the numbers will be encountered will be rational numbers. So what's a rational number? A rational number is the result of dividing two integers. Said differently, A rational number is a number which can be written as a fraction whose numerator and denominator are both integers. Remember that since division by zero causes a fundamental problem, the denominator of a fraction represents a rational number must not be zero. All right. Said a little bit more simply, right? Just remember that it is illegal to divide by zero. We cannot divide by zero, right? We divide by zero, it's gonna cause issues. All right. All right. Do, do, do. So then next we want to talk about decimal representation, right? So fractions are not the only way to represent the result of a division. Using long division, the quotient of two numbers can be expressed in decimal notation. All right, let me give y'all an example, right? Say I had 1 over 2, right? Now I want to convert this to a decimal, right? So I'm telling you that this bar right here, that means division, right? So literally, this is what? 1 divided by 2. That's another way of writing it, right? To do this out, you could do what's called long division. I like long division, right? So you take your denominator, put it on the outside, numerator on the inside, and then you just go step by step. 2 goes into 1 0 times, and then 0 times 2 is 0. Subtract this. This is 1. Put a decimal point right here, decimal point above, right? Add a 0, bring that down. Now 2 goes into 10 5 times, right? And then 5 times 2 is 10. Subtract that, that's 0, right? So what am I telling you? I'm telling you that 1 over 2 is equal to 0.5, right? And that's how you change a fraction into a decimal, right? In case you guys encounter that on your homework, real nice and simple. Okay. So changing from fraction to decimal, to change a fraction to a number in decimal form, perform long division of the numerator by the denominator. That's it. That's a secret sauce. All right. All right. One of the unfortunate features of decimal representation of numbers is that they may not terminate nicely. So, as the previous simple example did, right? For example, 1 divided by 3 is equal to 1 over 3, which is equal to 0.3. And this line on top, that means that it's repeating. So, it means it's 0.3333333, right? A basic fact of rational numbers, however, is that their decimal representation must either terminate or repeat. All right. Good stuff to know. So now I want to talk about another type of number. All right. So other conventions, mixed numbers. So you may recall that fractions whose numerator is small in magnitude or smaller in magnitude than the denominator is called a proper fraction. For this reason, a fraction whose numerator is greater than or equal to the denominator is sometimes called an improper fraction, right? However, there is nothing improper about improper fractions at all. We will work with them routinely. In fact, in most circumstances, it is better to work with improper fractions than their alternative. I agree. However, there is another common way of expressing improper fractions. These are what's called mixed numbers. All right. So a mixed number has an integer part and a proper fraction part. To convert from an improper fraction to a mixed number, you have to perform the indicated division. The quotient will be the integer part of the mixed number. The remainder will be the numerator of the proper fraction part. The denominator is the same as the denominator of the original improper fraction, right? That was a lot. Let's go through an example, right? Just making this up off the top of my head. Let's say that I had 22 over 7, right? 22 over 7. And let's say that I wanted to change this into a mixed number, right? What am I going to do? I'm going to do the long division, same thing we just did before, right? So the denominator goes on the outside, numerator on the inside, right? So now 7 goes into 22, I know 3 times, right? And 3 times 7 is 21. Then I'm going to subtract that. That's 1. Put a decimal point here, decimal point above. Put a 0, bring that down. Now 7 goes into 10. I know 1 time, right? And 1 times 7 is 7. You guys get the idea, right? Bring a 0, bring that down, right? Now 7 goes into 30. How many times does 7 go into 30? Right? I think that's like 4, right? And then 7 times 4 is 28. It's going to leave back a 2, etc. Right? This is going to go on forever. But the idea that I wanted you to see, right, is that we can continue this to make it a decimal. But let's talk about a mixed number now, right? Let's say I didn't want to continue going through all of this, right? Let's say I just wanted to change this into a mixed number. How would I exactly do that? Let me show y'all. I'm just going to erase some of this. All right. We're going to do this problem again, right? So once again, we know that 7 goes into, oops, sorry about that. All right. We know that 7 goes into 22 3 times. 3 times 7 is 21. And then that leaves back just 1. From this, I can actually change this into a mixed number. So the number that's above, right, the line, that's going to be your big whole number. Boom. Right? The remainder is going to be the numerator of the fraction. And then whatever you were dividing by, that's going to be the denominator. So that's going to come here. Right? And this is your mixed number. In case you don't want to do that fraction, excuse me, that decimal point stuff, you can go straight into the mixed number and call it a day. Questions on this, anybody? We good?
Professor,
Yeah.
my name is Danny Ramirez. Sorry if I came late.
No
The
worries.
public transportation is not working as well in my state. So, can you hear me very well?
Yep, I can hear you. No worries. You're all good. No problem.
Hello? Okay,
You
sure.
hear me?
All
Okay,
right.
good, good, good.
So, I don't understand anything. Honestly
I
to you,
got
I
you.
don't
We
understand
we we just
anything.
starting out today. Don't worry.
So,
Today's gonna be a
yeah.
simple day.
Yeah, yeah.
I got you. Yeah.
All right. Yeah, I see that. So, I see that.
Yeah.
Yeah.
It's not
Get
gonna be
started.
too hard today. We're just starting out. We're gonna start out real simple, real basic, and then we're gonna build from there. All right. Today we're basically just doing
Assignment.
arithmetic. That's all this is, just basic arithmetic.
You are the teacher. You are the math teacher, right?
I am. Yeah. All right. So let's
Okay.
continue. So notice that 3 1 over 7 actually means 3 plus 1 over 7. So this is an unfortunate notation since normally the absence of a symbol for an operation between two numbers implies multiplication. But at this point, the notation is a historical fact of life. So to convert from a positive mixed number to an improper fraction, you multiply the integer part by the denominator of the fraction part and add the numerator of the fraction part, right? And then that the result will be the numerator of the improper fraction. And then the denominator of the improper fraction is the same as the denominator of the fraction part of the mixed number. Okay, okay. Let's talk about this one real quick. All right. I'm gonna give you guys an example.
Mr. Lee, for the improper fraction, that's the one that has the whole number plus the fraction, right?
It's the improper fraction is like a bigger number. So like 22 over 7, that's improper, you
All right,
know?
that's
But a
improper.
proper fraction would be like 2 over 3, all right? But now
And
let's
what's
say
the
that
name?
I go ahead.
What's the name of the one that we just had where it was 3 for the whole number plus 1/7?
That's a mixed number.
All right, and that's the
Mixed
mixed number.
number. Yeah, yeah.
Yeah, because we keep on saying all of the same words over and over so many times, and improper fraction and mixed number. I don't want to confuse them in between.
Got you, got you. Yeah, I'm just giving y'all techniques to answer your questions basically. You know, make it a little bit simpler. All right, let's say I take a mixed number, right? I'm just making this up. Let's say I have 5 and 2 over 3. All right. Now I want to change that to an improper fraction, right? So that means that the numerator is going to be real big and the denominator going to be real small, right? So I'm trying to change that to an improper fraction. So here's how I do this, right? First thing you do, you take your integer part and multiply it times your denominator, right? So then this is going to become
Not to cut you off again, the integer is always the whole number.
exactly, exactly,
Okay.
right? Multiply it by the denominator, right? And then all you're going to do after that is you're going to add it to the numerator. And then you always keep the same denominator. So very simply, 5 times 3, that's 15 plus 2 divided by 3. And then 15 plus 2, what's that, like 17? So then like 17 over 3. That's it. All right. So you take the whole number, the integer, the big number, you multiply it times the denominator, the bottom of the fraction, right? And then you add whatever the numerator is to that number that you just got, and then boom, you have your numerator for your improper fraction, and you're gonna divide it by the same denominator, right? Same denominator. Doesn't change. All right? Questions on this? As I said, if you guys like, y'all could start looking at the homework. All right. All of this is there. All right. Homework is also a great, great way to prepare, right, for your exams. All right. So, graphical representation of fractions. So you
Can you
may
let the
remember.
example for us?
Say it again. I'm sorry.
Can you let the example for us for the assignments? Like there, so that one I understood very well.
Awesome.
It's so easy.
Awesome. So yeah, when you go into the assignments, you'll see they're very similar. Go ahead, Carmen.
Yes, so that you just did, that was just changing a mixed number into an improper fraction, right?
Correct. Yeah.
Okay, no, just wanted to make sure that that's what.
Yeah, yeah, yeah. That's what we just did. All good, all
Thank
good.
you.
All right. Let's look at 1.4. This is a graphical representation of fractions. So you may remember from your youth seeing your math teacher draw pictures of pizzas on the board to illustrate a way to represent fractions. So throughout this text, the most convenient way to represent numbers, including fractions, will be pies. Give me 1 second. want y'all to see this. So we'll be using a number line. All right, we all remember what number lines are, right? Like this is a number line right here. Okay. So by using a number line in this representation, every number will correspond to a geometrical point. The key features of a number line are it extends infinitely in both directions. One direction is designated the positive direction to the right, while the other is the negative direction to the left, right? There is one distinguished point on the line representing the number 0. And 4, there is a unit distance with one length, excuse me, with length 1, right? Which allows us to mark off all the points representing integers. Proper fractions, at least the positive ones, are then represented by points lying between those labeled 0 and 1. The denominator tells us how many units to subdivide the segment between the points labeled 0 and 1. The numerator tells us how many of these subunits to count from 0, right? Improper fractions are handled similarly. For these fractions, it is more convenient to represent the number as a mixed number. Instead of dividing the segment between the points 0 and 1, we divide the segment starting at the points representing the integer part of the number and the next point representing an integer away from the point representing 0. For example, think of the improper fraction 22 over 7 as a mixed number 3 and 1 over 7. We can represent this number with a point 1 over 7 of a unit between 3 and 4. All right. So we already saw that 22 over 7 was equal to 3 and 1 over 7, right? So if I wanted to graph this on a number line, right? First off, I know that my whole number is 3, and I know that the next whole number after 3 is 4, right? So boom, my whole number is 3, and the next number after that is 4, right? Now to correctly graph this, right? My denominator is what? 7, right? So because my denominator is 7, I need 7 marks. 1, 2, 3, 4, 5, 6, and this would be the 7th one, right? In between these two numbers. And then how many marks am I going to go over? Just one, right? To get where the 22 over 7 would be, because the 22 over 7 is 3 and 1 over 7. So I'm going only one space over to mark it. Cool, right? This is how we graph improper fractions on a number line, right? Had this been a proper fraction, like 2 over 5, for example, right? You would actually be doing that between 0 and 1, right? And that's the only difference. Not the hugest fan of graphing, but it is what it is. So the next thing I want to talk about is something called equivalence fractions, right? Equivalent fractions. So I remember seeing this on the homework. So equivalent fractions and fractions in simplest form. All right. Oh, sorry. Hold on. I clicked the wrong thing. Sorry about that. Sorry about that. All right, coming back. So one of the most important features, right, of fractions is that two different looking fractions might represent the same number. So when you think about it, this shouldn't be a big surprise. After all, there are many different division problems that give the same result. So, for example, 9 divided by 3 is the same as 6 divided by 2. Both the answers are 3, right? That's one way to see that fractions, 9 over 3 and 6 over 2, are different ways of symbolizing the same number. Two fractions are called equivalent if they represent the same number. The basic principle we will need to keep in mind is the following. Multiplying or dividing both the numerator and denominator of a fraction by the same non-zero number gives an equivalent fraction. In fact, this produce amounts of multiplying this procedure, excuse me, amounts to multiplying a number by one, which of course does not change a number, right? Because one times anything is itself, right? So there are two main reasons that we will be interested in equivalent fractions: writing fractions with common denominators and writing fractions in simplest form, right? So one question that you might get, I'm just thinking of one off the top of my head. Um, let's say, I'm just gonna keep it real simple. Let's say I had 2 over 14, right? And then I wanted to simplify this, right? So now I have to think to myself, what is a number that goes into the numerator and denominator evenly, right? So I can rewrite this as what? 2 times 1 over 2 times 7. And I notice they both have 2's, right? So this would be my reduction. I could cross those out and leave this as 1 over 7. So 2 over 14 and 1 over 7, these are equivalent fractions, right? And that's basically it, right? That's how, if I want to go from a larger fraction to a smaller, I can even do it in reverse. Say I have 1 over 3, right? And then let's say that I multiply this, like multiply the top. Hold on. Let me not do that. Let me say it like this. Let's say I multiply the top by, I don't know, 2. And I multiply the bottom by 2. This gives me what? 2 over 6. 1 over 3 and 2 over 6 are equivalent fractions, right? How you spell that? Equivalent, right? The equivalent fractions. Same thing as over here, right? Equivalent. So on your homework, right, you're going to have some questions where you might have to take a big fraction and then change it into a little one. Or the reverse, you might have a little fraction and you need to multiply it by something to make it into a bigger fraction. Right? Simple, simple stuff. At the end of the day, the two fractions, when you do the math on them, will be equal. All right. But now let's make it just a little bit harder. Just a little bit harder. Excuse me. Just a wee bit harder. So now we want to write fractions with common denominators. So as we see below, right, there are situations when we would like to write two fractions as an equivalent way so that they have the same denominator. I forgot to give you the example. Let me get that for you real quick. All right. 1 second. So let's say I had a situation like this, right? For example, you want to write these fractions 3 over 10 and 7 over 15 with a common denominator. Why would I want to do something like this? Let's say that I had to compare, right? I had to compare these two fractions And like, let's say I needed to know which one was bigger than the other, right? For whatever problem, whatever reason I'm doing this, right? Then, hold on. All right. Then, right, it would be easier if I had the same denominator because then I can just compare the numerators. Whichever one who has the larger numerator, that's the bigger one, right? So let's say I have 3 over 10 and I have 7 over 15, right? Now I need to make their denominators the same, right? So here's one way that you can do it, right? I have the 10 and I have the 15, right? Go through the multiples of 10 and go through the multiples of 15, right? I think it's better as a technique, right? Go to the larger number and see the multiples, right? So 15 times 1 we know is 15. 15 times 2 we know is 30, right? Now you see, I'm gonna stop at 30 because I know that 30 is the answer, right? But you see, if I went through the top, I would have 10. 10 times 1 is 10. 10 times 2, 20. 10 times 3, 30. It's more work to go through the smaller number. So the trick is, right? The number that has the bigger denominator, right? Go through the multiples of that and and stop when you land on a number that goes into the smaller denominator. So okay, I know that 30, right? That's my common denominator, right? My least common denominator at that, right? How can I change get another color for this? How can I change a 10 into 30, right? Like what number would I have to multiply the 10 by to make it into 30? Right? So that would be 3, right? But what I do to the bottom, I got to do to the top times 3. Just like that, right? So now what do I have? I have 9 over 30. Now, same game as before, right? I want to change this 15 into a 30. So what do I have to multiply that by? By 2, right? But what I do to the bottom, I got to do to the top. So now what do I have? I have 14 over 30. But which one of these are bigger, right? The 9 or the 14? Obviously the 14. So you could tell, right, that 7 over 15, this is the bigger fraction, right? That's the bigger fraction than the 3 over 10. That's how you would prove it. I kind of did an extra step there, right? Showing you guys the comparison. They were not asking us to compare it. They were just asking for the actual numbers, 9 over 30 and 14 over 30. But just to show you a reason why I would want to do this. All right. All right.
Did you say you're gonna let us do the last one?
That
As
was a
you
little
said.
wait, that was a little choppy. I couldn't hear. Maybe try typing it because that the microphone wasn't clear that time.
All right, you say you're gonna let us to do that one? 9 over 30, 14 over 30, or you gonna explain it?
Yeah, that's it. That's the answer. So the question was this. You have 3 over 10 and you have 7 over 15, right? So I want to write them as a fraction with the same denominator, right? So you just have to find the LCM, least common multiple, and boom, that's it. But the process that I like to go through with doing it, I take the larger number, right? The larger number right here. And then I like to go through the multiples of the larger number until I hit a multiple that is going to also be in the smaller number. I knew that it was 30, so that's why I did that. I could have, technically speaking, because all they asked for was a common denominator, I could have used 60, right? I could have said 45 and I could have said 60, and 60 would have worked too for both of this as well. But it's easier to just use the least common denominator, right? And that's a process that you can go through to find that. Again, totally good with you guys using a calculator, so don't stress this. Like I want y'all to use your calculator and figure this stuff out. All right. Especially on your homework. That's the homework is the best place to get your calculator practice in. You know? All right. So writing fractions in simplest form. A fraction is said to be in simplest form when the numerator and denominator have no fractions in common, except one, right? So for example, the fraction 8 over 52 is not in simplest form since 4 is a factor of 8, right? So since 8 equals 4 times 2, and 4 is also a factor of 52, right, which is 4 times 13, when dealing with large numbers as numerators and denominators, it is sometimes helpful to see their prime factorizations, right? And we will not emphasize that here, but most of the time it will be able to see common factors without much trouble. So let me show you guys what a prime factorization is real quick. Carmen, go ahead. I'm sorry about that. A question, Carmen, or are you good?
Your mic is muted.
No, I was gonna ask to the other to the other problem, but the answer was 30. Like the
Yeah,
if you that was an extra question, like which one was larger, but the question was actually which one was the common denominator, which was 30.
right. Exactly. Hmm.
Okay, no,
And
thank you, no
why you would
problem.
have done it. You're welcome. All
So
right, so
either way was right. Okay.
yeah, yeah. So something that I want to show you guys real quick. This is a really, really handy technique. I personally use this all the time. This technique is a technique that kind of unlocked me from the calculator because I used to be very, very heavy calculator dependent, you know? So this is called prime factorization. So the way that you do it, right, and I'm going to use it to answer this question, but the way that you do it, you take one of the numbers, I'm going to take 8, for example, right? And you just break it down to its basic prime factors. So basically, give me two numbers that multiply to give me 8. So what are two numbers that multiply to give me 8? Somebody.
4 and 2.
Exactly, right? So 4 and 2. Now 2 is a prime number. And how do I know it's prime? Because it's divisible by only 1 and itself only, right? How about 4? Give me two numbers that multiply to give me 4,
2.
right? 2 and 2, right?
Two.
So bam. So what am I trying to say? I'm trying to say that 8, right, is literally equal to 2 times 2 times 2, right? Let's try 52, right? Now,
Let's
here's the
see.
beauty. Go ahead. I'm sorry. All right, so here's the beauty about 52, right? Now, sometimes when you look at these numbers, you might not be able to tell what is the best the largest perfect square that goes into it or whatever, right? So just break it down small and simple, right? So this is 52. I know that I could divide 52 by 2. So let me do that. So if I break this down by 2, the other number is going to be what? Like 50, excuse me, I'm sorry. Like 26, right? Cuz 26 times 26, excuse me, 26 times 2 is 52, right? And then if I break down the 26 further, this would be like what? 2 and 13. So I'm telling you that 52 is equal to 2 times 2 times 13, right? Now, if I'm going to simplify this, all I have to do is knock out the same number on the top and the bottom, right? So what's a similar number on the top and the bottom? I have 1, 2 here, I have another 2 here. I have 1, 2 here, I have another 2 here. right? But these two numbers are different, right? Those two numbers are different. So whatever's left over, that's the simplest form, the reduced fraction, right there. Any questions on this?
And this is how you find the prime factor, you said?
This is how you get the simplest form of a
Simple.
fraction. Yeah. Because sometimes you have a big fraction and you want to reduce it to like its simplest terms. This is how you do it. Now, this process that I just showed you will literally work for every single fraction that comes across your way, right? But you can be a little smart about it. So some people might have said, oh, I got this, right? 8 over 52. I know that 8 over 52, this is just 4 times 2 over 4 times 13. Some people could see the 4, and that's okay. It'll lead you to the same answer, right? If you can see the 4, good for you, right? But if you see two numbers and you have no idea what to do, this is the technique for you right here, the prime factorization. I promise you it will always, always, always work, right? Always, always, always. All right. Questions? Anybody?
Well, basically, that's just reducing the fraction.
Exactly. That's all I want to do.
So this
I'm
process was reduce the fraction.
Yeah. Yeah, I'm just showing you a easier way in my opinion on how to do it. If you have your own method that's been working for you for years and stuff, go ahead. I'm not stopping you. Go ahead, do your thing. All right.
So simplifying the fraction is the same thing as reducing the fraction.
Exactly.
Okay,
Yeah.
got it.
All right. Hmm. I am going a little fast because I feel like most people get this, but if you guys have a question, please don't hesitate to ask. Please don't.
Can you, Christopher?
Yep.
I got a question. Can
Go
you
ahead.
write your Gmail in case we have a like any issue with the assignment? Can you help to us?
Yeah, yeah,
So
yeah.
can I send you any email if I have any issue with the assignment? Can you write it down before you finish your classes? You're
Yeah,
gonna
yeah,
be
yeah.
with us 4 to so you start at 4 p.m. to 5:50, right?
Correct.
Viste relajo.
Yeah.
Your class is 4 p.m. to 5:50?
Correct. Correct. Yeah, so this is my email right here.
Yes?
I'll show you. Yep, that's correct. That's correct. So this is my email. It's Christopher, my first name.
Yeah,
dot
write it down.
Lee.
Write it down for us and we can take it if we have any issue.
I got you. So it's my first name, Christopher, dot Lee, Lee, my last name, 02, and then at bcc dot cuny dot edu. All right. You guys can also find it on Brightspace when you log in. All right. It's there in the About Me section. All right. And that's it. Yeah. So yeah, shoot me an email if you need any clarification. Um, Something I didn't share with you guys earlier, like I'm actually a tutor in the tutoring lab, so you guys can actually book time with me for tutoring if you want. Completely optional, up to you. Remember that you guys have your own personal tutor in the class as well. You're going to meet her on Thursday, right? So you have a lot of help around you. So please, like, don't suffer in silence or anything like that. We're all here to help. We all want to see you succeed. All right. All right. So let's jump into this. Operations with fractions, multiplying and dividing. So now that we have reviewed the basic properties of fractions, we will review the rules for performing arithmetic operations using this symbolism, right? We will begin with multiplying and dividing. This might seem strange as you think that adding and subtracting are easier operations to work with, but since fraction notation is based on the operation of division, it should not be too hard to believe that multiplying and dividing are much more suited for the notation than adding and subtracting, all right? So Let's look at 1.1, multiplying fractions. So multiplying whole numbers has a clear relationship with the operation of addition. So for example, 2 times 3 means the same as 3 added together 2 times, or 3 plus 3. However, if we want to extend the operation of multiplication to fractions, negative numbers, and other more exotic numbers, we have to make sure that certain basic properties are preserved, like the commutative and associative properties, which in the case of whole number multiplication are just easy consequences of the corresponding properties for addition. In addition, multiplication and addition must be related by the distributive property. So we will not review these properties here. We only mention them to indicate that the rules for multiplying and dividing fractions are not arbitrary, but are carefully considered so that all our basic operations interact in the same way we expect them to do based on our experience with whole numbers. All right. Long story short, we're going to be multiplying some numbers together. All right. So let me show y'all the trick. This is also on your homework as well, in case you're wondering. So we're going to talk about multiplying fractions. All right. So the product of two fractions is a new fraction whose numerator is the product of the two numerators and whose denominator is the product of the two denominators. All right. For example, right? Let's say I have 2 over 3 times 4 over 5. How do I multiply the fraction? Very simply, straight across. Straight across. All right. So this becomes what? 2 times 4 over 3 times 5. And then just do the multiplication. 2 times 4, 8, 3 times 5, 15, and that's it. Questions on this? This good?
Yes.
All right,
Well,
good.
Yeah, can you repeat it one more time? Sorry.
I
Can
got you.
you
So,
repeat this one more time? Two over three times four over five.
right. So whenever I'm multiplying fractions, right? All I have to do is multiply the numerators together over multiplying the denominators together. The way I like to say it is straight across, right? So when I have 2 over 3 times 4 over 5, right? All I have to do is just go straight across. This becomes 2 times 4 over, right? The 3 times 5. And the rest of it is basic multiplication. 2 times 4, 8, 3 times 5, 15, and then that's it. Yeah. And leave it in a fraction as well.
Gotcha. Thank.
Yeah. You're welcome. Yeah, you guys will have a couple homework questions like that, so you'll get some practice in. All right.
All the assignments we have to do it at in the computer. Every
Yes.
homework,
Yes.
every. So I'm asking many questions because I'm fresh.
No problem.
I'm fresh. I never been in college before,
No
so
problem.
this is my first speak.
No problem. No problem. We can go over how to work the internet and everything. So try this out, you guys. And I'll leave the notes up. 1 over 4 times 2 over 3. Try it out for a second and then we'll go over it.
you ready?
I'm sorry?
Uh-uh.
Next example, multiply. That's easier. So just one time. 1 times 2 is 2,
Mhm.
right? And 4 times 3 is 12.
Okay.
Is that right?
Let's see. So,
Mm.
Yeah. He did it. JS did it. Yeah, 212.
hmm
Yeah.
so let's do that real quick. Hold on. Where's my pen? 1 second. Well, we done froze. Give me 1 second. Give it a second to load. Okay. All right. I feel like sometimes that happens with the colors. Good. There we go. There we go. There we go. All right. So let's try it out. So I have 1/4 times a 2/3, right? And you multiply straight across. Becomes 1 times 2/4 times 3. Very good. So this becomes 2/12. Everybody got that?
Yeah.
All right. What am I supposed to do after that?
Yeah.
Simplify it.
Simplify it, right? So help me out.
Divide by 2.
Good, good, right? This is like 2 times 1 over 2 times 6. These are alike. So this will be my answer, 1/6. Not bad. Very good. Any questions on this, anybody?
Yeah, I got a question.
Go ahead.
Why we have to simplify and we just can't leave it like that?
So I want you guys to learn how to simplify. I will admit, in when we get to like statistics and stuff like that, I really don't like simplifying, right? But I want you guys to have that skill set so that like in case you encounter in your other classes like sociology or psychology or something and they you get a fraction and they ask you to simplify it, I want you guys to know how to do that.
Oh, okay.
Mhm.
Thank
Yeah.
you.
But to be totally transparent with you, when we do encounter fractions in statistics, I'm not a fan of simplifying at all.
Okay, thank you.
Yeah. You're welcome. Yeah. And I'll explain why when we get to that topic.
I have a
Mhm.
question.
Go ahead.
Um, what happens if we have letters in the fractions?
If we have letters in the fractions,
Yeah.
give me an example of what you're saying.
I'm just gonna take it from the homework.
Go ahead.
Um, like A over 4 and B over 10.
When you say and, is there an equal sign, a multiplication sign, plus sign?
Oh, it's a fraction. I didn't say and. I said over.
Oh, like A/4 over something else like that?
Yeah, A over 4 equals to B over 10.
That's it?
Yeah.
All right. So this is a similar question like what we had before, right? I want to make their denominators the same, right? That's the trick right here, right? So
Uh,
what is a number that they both go into, right? So we have 4, we have 10. Again, I like to start with the bigger number, right? So 10, I know that 4 doesn't go into 10 evenly. Let's say 10 times 2 is 20. Can 4 go into 20? It can, right? That would be 4 times 5, if I'm not mistaken, right? So 4, 8, what's that? 12, 16, right? And then finally 20, right? So now what number would I multiply the 4 by, right? To make it into a 20, it would be 5. What you do to the bottom, you gotta do to the top. And what number would you multiply the 10 by to make it a 20 by 2? What you do to the bottom, you do to the top. This is not really answering the whole question. I wonder if there's more to the question, but very simply, you could say that 5A and 2B are equal.
there is more to the question. I was just confused about the two. That was
Got
it.
you. Got you. Okay. All right.
All right.
I'm
Thank
still don't
you.
understanding that one.
So there's a question that you
That
have.
part is difficult.
I got you. So look, there's
Hey,
a
Chris.
there's a question that they have where they're gonna give you multiple fractions and they're gonna ask you what would the numerator be of this fraction, what would the denominator be of that fraction. So you have to use the fractions next to you to get the answer, right? Remember that all of those fractions are equivalent. They all equal the same thing, right? It's just that some of them are multiplied by 3, some of them are multiplied by 5, some of them are multiplied by 2. That's the
How
only.
you got okay. All right, Chris. Yeah, okay. Give me a
Yeah.
second, please. How
Mhm.
you got 5, please? I'm sorry. How you got
Oh, the
5?
5? Because 4
How you
times
found
5 is
how you
20.
how you found 5?
Because 4 times 5 is 20.
So, Mr. Lee,
Okay, okay,
we
you
going,
got okay.
Yeah.
Mr. Lee, were we going to go over that and the following? Like, you know how you're going through it right now? Was
Yeah.
this coming up? The problems with the variables?
No, we did that already. Long story short, the trick how you do it, you get the same denominator, right? And then you work with the numerator. Mhm. You'll see. Try it out for homework, right? If you don't get it, that's okay. Tomorrow in class, excuse me, Wednesday in class, right? I'm gonna ask you guys if y'all have any questions. Just bring that question to me, and I'll show you how to do it step by step. But I feel like if you stare at it for a little while, I feel like it'll come to you. Hmm. All right, let's try something else. Let me see. How about this? New question. I'm gonna let you guys try that out. So that's 15 times 4 over 7. Try that out. I want to multiply them, not add. I want to multiply them. All right. How we looking on this one?
I don't know the answer. I need to
Okay.
learn a little more.
All right. What's another way that I can write 15? Somebody tell me. If I wanted to write 15 as a fraction, what would that be?
What is the another way? Right?
Yeah.
Five times 3.
True, true. I get what you're saying. But I want to write 15 as a fraction, right? Because I know how to multiply fractions, but I don't know how to multiply whole numbers, right? So how can I change 15 into a fraction? I can write it as 15 over.
1.
Perfect. And after that, just go straight forward, right? 15 times 4, what's that? Like 60 over 1 times hold on, let me write that out. Let me not do it like that. 15 times 4 over the 1 times 7. So that's like what, 60 over 7. And that's it. As an option, if you don't want to leave
That's
it as
it.
a, go ahead. I'm sorry.
Okay.
Yeah. As an option, if you don't want to leave it as an improper fraction,
No, no.
just go
I
straight
just
mixed
repeat
number.
it.
Okay, okay, no problem. But yeah, if you don't want to leave it as an improper fraction, you could change it to a mixed number, right? Remember to change to a mixed number, you're gonna do your division like so, right? So 7 goes into 60 how many times? Ooh, what's that? Um, I know it's not 10. I know it's not 9. It's probably 8, right? So let me see. 7 sevens, 14, 28. what's that? 56, I think 8, something like that. 56. All right. Yeah, I think that's right. And that gives me a remainder of 4, right? So if I'm changing this into a mixed number, right? Remember, whatever number goes in evenly, that's going to be your big integer. Then the remainder, this is going to be your numerator. And always, 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 we always keep the same denominator, right? Questions about this?
And always it will be 1. For example,
If
if
it's a
you say
whole number,
17 times 5 over 7 is gonna be
17 over 1. Yeah.
5 over 1.
Yeah. Mm-hmm.
Okay,
So anytime you
always
have a
over
whole
1,
number, you
always
can
over
put it
1.
over
Okay.
1. Mm-hmm. Very good. Let's see. Let's talk about dividing fractions. Okay. So to divide fractions, we will take advantage of the fact that division is the opposite of, or more precisely, the inverse operation of multiplication. In order to take advantage of this fact, we recall the idea of the reciprocal of a number. So two numbers are reciprocals if their product is 1. In practice, to find the reciprocal of a number written as a fraction, we interchange a numerator and denominator. So, for example, 2 over 3, right? The reciprocal of 2 over 3 is 3 over 2, right? So if I asked you for the reciprocal of 2 over 3, you just kind of flip them, right? Denominator goes up top, numerator on the bottom, that's it, right? Now, let's say that you were unsure about this. Did I do this right? Right? Always remember this. Two numbers are reciprocals if their product is 1. So product is another word for multiplication. So if I multiply this, what do I get? 2 times 3 over 3 times 2, which becomes 6 over 6, which is just 1. So I know that they are in fact reciprocals. And that's it. That's how you do a reciprocal. You flip the fraction. Top on bottom, bottom on top. That's it. Questions on that?
Oh, good.
Good. All right. Um, let me see if y'all really good. Let me see if y'all really good.
Yeah, because that's kind of easy. It's the same numbers.
That was kind of easy. All right, all right. How about this? How about this? All right. What about this one? If I told you that the reciprocal of 4 is equal to 4 over 1, right? So the reciprocal of that would be 1 over 4, right? So what's the reciprocal of 17? What's that going to be? The reciprocal of 4 is equal to 4 over 1, which gets flipped to 1 over 4. So what's 17? What's the reciprocal of 17? Not sure?
When it becomes 17 over 1?
Yeah.
Okay. And then what are you going to do with 17 over 1?
You're going to multiply it times 1 over 17?
Okay, so you want to prove that that's the reciprocal. I got you. Multiply it times 1 over 17, and that gives you 1. Really, what I wanted you to say was that for 17, the reciprocal, right, is going to be 1 over 17. Just flip it. That's all. That's the reciprocal. So if you have
Yeah,
any questions, go ahead.
like it wasn't really a question because all I see is the number 17. Before we had it already written out.
Yeah. Basically, like when you get to the homework, if they ask you what's the reciprocal of this number, just flip it. And that's it. Just flip it.
So just first flip the fraction, right?
Exactly.
So the reciprocal of 17 is 1/17.
That's it.
All right, no doubt. Got it.
And the reciprocal of like 2/5 is 5/2. That's it. All right. Just flip it. Let's look at this. The quotient of two fractions is the same as the product of the first fraction by the reciprocal of the second fraction, right? So, for example, we write 3/4 divided by 2/3 as 3/4 times 3/2, right? You guys remember this? Keep, change, flip, right? How you do F again? That's how you do F. Keep, change, flip, right? So I have 3/4 divided by 2/3. I want to get that answer. So what do? You keep the first number, change the division to multiplication, flip the second number. And then after that, you know what to do. Just go straight across. 3 times 3 over 4 times 2, 9
And,
over 8. And then that's it.
and you do keep, change, flip when we're trying to do
When you have
the
division.
fraction.
No, when you have division, that's when you do keep, change, flip.
All right.
When you have multiplication, just go straight across. Boom, boom. And that's it. Man. All right, try this out for me. So I want to divide 7/8 by 3/4.
Seven over 8 by 4/5/3 because you flip the second numbers
Okay. Let's see.
and
So I
you
have
let the
7/8.
first numbers equal 7/8, 7/8, and
Mhm.
by
By what? So you want to flip it, right?
times
Mm-hmm.
7 7 times 3. Well, I don't know.
Mm-mm. So remember,
Three times.
say it again.
8. 3 times 8.
Right. So what you want to do, you want to keep the first term, you want to change the division to multiplication, and then you want to flip the last number, right? So this becomes what? 4/3.
I got
Right?
28
Yeah.
or 24.
And then now you can just go straight up.
Okay. Well, I'd say good.
Yeah.
Exactly. 7 times 4 and
Like
8.
20.
Yeah.
Yep.
Because you're gonna do it
Over,
like
what's
that.
that, like
Yeah.
24 or
7
something like that?
times 4.
Right. You could even reduce that a little bit
I
more if
got
you
you.
want.
Yeah.
Right. You could say that this is 7 times
Do
4.
another example.
And then you
Can
could
you
say
do
that
another
this,
example?
I got you. I got you. And we could say that this would be like what? 4 times 6. Kill the fours, and then this reduces to 7/6. Right?
That if you want, right?
Yeah, if you want to. I want you to know how to do it, but I'm not gonna like force you
Yeah, but
to
that's
do
not
it.
necessary, right?
Yeah, it's not necessary.
Or
On
you
the
have to
on
do
the
that
test,
always?
this is full credit for me on the test, to be honest with you.
Okay.
You could break it down even more to the next level, right?
Right.
Okay.
There's
28/24.
Yeah. And then we can even go a step further. We could change it into a mixed number, all that good stuff. But how about another example though, real quick?
Let's do it.
Do this for me.
Yes,
9/2
Mhm.
divide 15/1. And
Okay.
then
I like that stuff.
9, okay. 9/2, yeah, 15 over
Mhm.
1. And then you're gonna 9 times 1 and 15 up.
keep change flip.
Keep change flip. So we have 9/2 times
Change.
1/15.
Oh yeah.
And just multiply
Yeah.
straight across.
15.
Becomes 9 times 1 over
Yeah,
2 times
you flip
15.
it.
Let's call that
30.
9/30, right? If you want, you could reduce it by 3, right? This top becomes 3 times 3. This bottom becomes 3 times 10, which will reduce down to 3/10. But I would accept this. All right. Questions on this?
So basically, unless you ask to reduce to the lowest fraction, then that will be the correct answer.
Right.
So if we put, like, let's say I was to reduce it, then either answer will be correct, right?
Yeah. Because they're
Oh,
both equivalent.
okay.
Yeah. All right. How about this? So I have 5/4 divided by 12. And try that out.
We only got 6 problems for homework. That's the homework.
Yeah. Let me check
Not only
while
that,
you
not,
guys working that out.
but this is the homework that I'm looking at web work.
On web work, yeah.
All
So
right.
there's like 4 homework sets and there's a couple of questions in each, right? I did not get to do the adding and subtracting. So if you guys want, you can attempt to do it. All right, but it's okay if you can't do that. That's homework 3. It's okay if you can't do it. I didn't get to that topic as yet, right? But the rest of it you should be able to get through, no problem.
So here is 5/4
Uh-huh.
by 12/1.
Good. So the first thing you want to do, you want to
And then
rewrite
you're
this
gonna
one.
flip 1 yeah.
Let's see, 5/4. Hold on 1 second. Divided by 12/1. Good. And then what do you want to do after that?
Keep change flip.
Good. So this becomes 5
You
over
will
4 times 1/12. And what's the answer?
times,
5 over.
yeah, you flip the last one exactly. Then 5 times 1
Mm-hmm.
and 4
Over.
times 12.
Which is what?
5. So 12, 12, 24, 32, 40, 44
40,
or 42, something like that.
48.
48.
48.
Yeah,
There we go. And that's it.
48, yeah.
Yeah. All right.
Right.
So I guess we could call it a day for that. Do me a favor,
Let's
everybody.
see.
Type your name in the chat. So I'm gonna count that as attendance for everybody. All right. You know what? I apologize to everybody. I just noticed that you guys were dropping answers in the chat. I'm just now seeing them. Sorry about that. I'll be more mindful next time. Sorry about that. Yeah.
All right.
And then we're gonna see what happens tomorrow if we're going back to campus or not. If we do, then I'll definitely see you guys on Wednesday. Be honest with you, I haven't even looked at our classroom. I hope that our classroom is dope, but if not, we might have to change it up. As long as it has a working projector and stuff that we could work with, then we're good.
You just need first and last name, no upload ID, right?
Yeah, just your first and last name. That's cool. That's all I need. Yeah,
Hold down.
yeah, I appreciate that. And then after you type it in, you're good to go. That's it for today. Unless you guys have any questions, then throw them my way.
No questions. All right. Thank you, Mr. Lee. Have a good one.
All right, you too. I'll see you.
I'll see you on Wednesday.
See you on Wednesday. Remember, start the homework. All right, it's really, really simple.
Homework is due
Except for
tonight.
one. You guys have time to get it done, right? I would prefer if you guys could get it done before next class. That way, you guys can present me with any questions that you might have. But if not, it's okay. Just do your best.
All right, no doubt.
I appreciate it.
All right, Chris.
All
I'll
right,
see you on Wednesday.
All right, Wednesday. See you soon. All right.